In this second video on factorization, we're going to look at taking out a common bracket as a common factor, which actually leads into grouping, which is going to be in the next video. But I want to deal with this as taking out a common factor following on from episode 1. So if we have a look at the expression that we've got here, we have to be careful to notice that we actually only have two terms. All of that is one term and all of that is one term, because we remember the terms are separated from each other by plus signs, minus signs, and in an equation by an equal sign. And this bracket here is meaning multiplication of this by the 3x, so all of that is remaining as one term. So if we look at the two terms that we've got, the only thing that we have in common is the bracket 2 minus y. So we're going to take out as our common factor the entire bracket 2 minus y, and then in the second bracket we're going to put down what's left over from each term. So once we've taken out this bracket, we're left with 3x, and in the second term, once we've taken out the brackets of 2 minus y, we're left with 4. And that's all we need to do, and we've now factorized that algebraic expression. Let's have a look at 7a bracket x plus y minus 3 bracket y plus x. So if we look at those two terms, it would appear that the brackets are not the same, because we've got an x plus y and a y plus x. But we then need to go back and think about the properties of numbers, and whenever you get confused, try to substitute these variables with actual numbers to test what's going on. So let's say x is 3 and y is 2. Then we'd be looking at 3 plus 2, and 3 plus 2 is 5. And then if we looked over here, we'd say, okay, the y was 2 and the x is 3, so we'd be looking at 2 plus 3, and 2 plus 3 is also 5. So we must realize that when there's a plus sign between these, even though the order of the variables or the order of the numbers has been changed around, it makes no difference, because that's an example of the commutative property, where it doesn't matter whether you say 3 plus 2 or 2 plus 3, you're getting the same answer. And the commutative property only works for addition and multiplication. So in this case, these two brackets actually do have the same meaning. So I am going to be able to take out a common bracket, and because we normally write things in alphabetical order just because our brains process it better, I'm going to write it down as x plus y. If I wrote it down as y plus x, it would still be correct. And then left from this term, I have 7a, and left from that term, I have minus 3. Let's look at what happens if we have 5m bracket n minus 1 minus 6 bracket 1 minus n. Right, so we've got a similar situation to what we had over there. The only difference is there the two were swapped around with a plus sign in the middle. Here the two are swapped around with a minus sign in the middle. So let's do a test with numbers as well. One of the values is already a constant, a number. So let's just give a value to n, and let's say I'm going to make n equal to 6. Then that bracket would become 6 minus 1, which is 5. And when I make, remember, if n is 6 here, n has to be 6 there as well. So this bracket would then become 1 minus 6, which is negative 5. So we can see that when there's a minus sign between them and they swapped around, the brackets don't have the same meaning. So what we have to do then is we have to try to make the two brackets the same. And we're going to use the identity element for multiplication, which is 1, to think about how to get around that problem. If we multiply anything by 1, the value stays the same. And you can test that as well. 8 times 1 is 8. 3,000 times 1 is 3,000. So if I multiply by 1, it makes no difference to the value. So I'm going to use the 1 in a slightly different way. I'm going to say negative 1 times negative 1 would give me negative times negative is positive, 1 times 1 is 1. So I'm going to think of 1 in a different way. I'm going to think of it as negative 1 times negative 1. So I'm going to multiply this value outside the bracket by negative 1, and I'm going to multiply the inside of the bracket also by negative 1, which in effect means I've multiplied it by 1, which means I haven't changed the value of anything. So I'm taking control of the situation and manipulating it in a mathematical way using mathematical rules to get it to behave the way I want it to. So the first term, 5m bracket n minus 1, I'm leaving exactly as it is. And remember, even when you're not working with something and you're going to come back to it later, you need to take it into the next step so that you don't lose it. So if I look here, I've got negative times negative is positive, and 1 times 6 is 6. And then in the bracket, I've got negative times positive, which is going to give me a negative 1 like that. And I've got negative times negative, which is positive, which is going to give me a positive n like that. So instead of writing it as negative 1 plus n, that looks rather messy, I'm going to write it as n minus 1. And now I have two brackets that are exactly the same. So we can't go through all of this rigmarole every time. I've done this to show you why it's happening, because I believe if you understand why something's happening, you can remember it in future. All you've got to remember is that when the situation arises where you've got the same things in the brackets with a minus sign and they swapped around, you're going to change the sign of the value outside the bracket, and you're going to swap the numbers or swap the terms inside the bracket, and then you will have solved your problem. So now it's just a straightforward example like the others were. I'm taking out the bracket that's the same, and what am I left with from this one? 5m, and from the other term I'm now left with plus 6 because it's changed its sign. Right, let's have a look at one last example. 2p bracket 3 minus q plus bracket q minus 3. Alright, so now that we know this whole trick, we're not going to do it the long-winded way. We're going to just apply what I've said, and that is we're going to write down the first term exactly as it is. And if you look, I've got 3 minus q and q minus 3. Both the terms are the same, but they're in the wrong order, and there's a minus sign in between them. So instead of writing all this out, that was just an explanation, I'm now going to change the sign outside the bracket, and inside the bracket, I'll still have a minus sign, but I'm swapping the terms around. And I know that I'm not doing anything illegal mathematically because I've proved over there why we're doing that. So now we have got two terms with a bracket each that's the same. So I take out that common bracket. From our first term, I'm left with 2p. And then a lot of people will close their bracket there. So you've got to be very careful and realize that when there's negative a bracket, it actually means negative 1 times the bracket. So what have we got left over from this term when you've taken out the common bracket? We're left with minus 1. And don't get caught out by that. If you've had two terms to start with, then once you've taken out your common factor, you're also going to have two terms left in the bracket, the second bracket.